Design a third order Butterworth digital filter using impulse invariance method. Assume sampling period equal to t equal to 1 second. So this is also a digital Butterworth filter using impulse invariance method. So before solving the question, first we just confirm that whether the analog transfer function is given directly or we have to derive the transfer function. So let's say in this problem they mentioned that third order Butterworth filter. As we know, the design step of analog Butterworth filter, I think fourth step, right? Fourth step is polynomial of the transfer function h of s is equal to 1 divided by Pn of s, right? So according to the order of the filter, we can write the denominator polynomial. So here that is mentioned as third order Butterworth filter. So here the transfer function is given as directly as the third order Butterworth digital filter. So no need to derive all the 6 steps. We can directly take it as h of s is equal to 1 divided by n equal to 3 means the denominator polynomial is s plus 1, s squared plus s plus 1, right? So in my previous video, here s plus 1, the poles are directly given, whereas the second equation s squared plus s plus 1, here we can't get direct poles, so we have to simplify for getting the poles, right? So as we know, the impulse invariance method, we have 3 formulas. One is 1 divided by s minus pk, another one is s plus a divided by s plus a squared plus b squared. So the first formula is suitable for this term. For this term, we can't find the poles directly. So here you have to remember that for simplifying this equation with the help of the second and third formula. That is s plus a divided by s plus a squared plus b squared. Another one is b divided by s plus a squared plus b squared. So that's the thing, you have to remember that. If that equation is easily find the poles, then you have to choose a first formula. If it is not find the pole directly, then you must do with the second and third formula, right? So for that, you directly do with that partial fraction method. So this is direct form, so we can do that a divided by s plus 1. This is not direct. So you have to simplify in the partial fraction method is ps plus c. ps plus c divided by s squared plus s plus 1. Let's find the ABC value. Now cross multiply this term. So a into s squared plus s plus 1 plus bsc into s plus 1 equal to this 1. Now simplify this. In both sides, LHS side and RHS side, compare the s squared coefficient, s coefficient and constant coefficient. In right hand side, there is no s squared and s coefficient. So that is 0. Only it having a constant value. So a plus b, s squared coefficient, right? This term and this term. A plus b equal to 0. Then yes, bs, cs. So a plus b plus c is equal to 0. There is no s coefficient in the right hand side. And constant value a, then c. So a plus c is equal to constant 1 right hand side. Now simplify these 3 equations, will easily find ABC value. So from this a equal to minus b, let's substitute a equal to minus b. So minus b plus c is equal to 0. These two terms cancel, so c is equal to 0. C is equal to 0 means a equal to 1. A equal to 1 means b equal to minus 1. So this is the ABC value. Let's substitute ABC value in these equations, right? So a value 1 divided by s plus 1 plus b value is minus 1. So minus bs plus c, right? So minus 1 into s minus s, c value 0. So minus s divided by s squared plus s plus 1. So 1 divided by s plus 1, this minus s divided by s squared plus s plus 1. So this is the our first formula model, right? S minus bk. Now this is not equal to the first formula, so it obviously second and third formula. So according to that formula, we have to modify this term. So what is that formula? S plus a the whole square plus b squared in denominator. So how it's possible to separate this denominator term as a s plus a squared plus b squared? So for that, I'm going to tell how to find this a value and b value by using calculator, right? So normally we can know that how to find poles in a calculator. The same method I am going to do in Calc. So first to press that equation mode, right? Equation mode, then degree mode. In degree mode here two values only. So plus 2. A value is what? Here A value is 1, P value is 1, C value is 1. So A value 1, then P value 1, C value 1. So x1 answer is minus 0.5. Here is not a direct pole, so it must be having a real term and complex term, right? So one is minus 0.5 is a real term. For getting complex term, press shift and equal. So what is that value? 0.866. This is one pole. Another pole is x2. x2 also minus 0.5, but imaginary term is minus 0.866i. So x1 is plus 0.5, right? Sorry, minus 0.5. Imaginary term is plus 0.86, whereas x2 is imaginary term is minus 0.86. So the two poles are what? One is minus 0.5 plus j 0.866. Another pole is minus 0.5 minus j 0.866, right? So from these two poles, you can take this 0.5 value is a 0.866 as a b value, right? Now let's simplify these two terms. We'll get the final answer is this one, s squared plus s plus 1, right? So here we can take it as 0.5 is a. So s plus a, 0.5 the whole square, plus 0.866 as a b value. 0.866 the whole square is a b value. Let's do it. Simplify this term. We'll get this one. We'll check it, right? So a plus b the whole square. A squared plus b squared. B squared 0.5 squared what? 0.5 squared is, one second. So 0.5 squared, 0.25. So a squared plus 0.25 plus 2ab. So 0.5 into 2, 1. So plus s. Plus here 0.866 the whole square. So 0.866 the whole square. Value is 0.749. Now add this value and this value, right? So 0.749 plus 0.25 is equal to 0.99, which is nothing but 1. So this is s squared, this is s. By adding this to, well, 1, get 1. So this is nothing but s squared plus s plus 1. So this equation is same as that of this equation. We just modified according to our formula, s plus a the whole square plus b squared. So this is the method to find a and b value. Okay, denominator okay. According to our formula, what is the formula? S plus a divided by s plus a squared plus b squared. So here a 0.5. So numerator also we have to form s plus a. So numerator we just having only s. So s plus 0.5 minus 0.5. Cancel this two term, will get s. So we can modify this s as a plus 0.5 and minus 0.5. So now separate the two terms. Minus, right? 1 divided by s plus 1 minus s plus 0.5. This is one term, right? This is one term. S plus 0.5 divided by s plus 0.5 the whole square, 0.866 the whole square. Minus into minus plus 0.5 divided by denominator term. This is the second term. So this is as per the first formula format. This is second formula format. S plus a divided by s plus a squared plus b squared. What about third one? Third one should be p divided by s plus a squared plus b squared. So here denominator okay, s plus a squared plus b squared. But numerator is not a b squared. Is not a b value. So numerator we should have 0.866. So for that you just divide this 0.5 to 0.866, right? So numerator as we have that 0.5 value, divide this one is 0.86, will give 0.577. So the above equation 0.5 is changed as 0.577 into 0.866. These two term is nothing but 0.5. So here we are not changing the term, we just modify it, right? So you just consider this term. This is what? P divided by s plus a squared plus b squared. This is constant value. Okay. So this is our first formula. This is second formula. This is third formula. So you just replace according to the formula. P value what? Minus 1. So 1 divided by 1 minus e power minus p z power minus 1. Then s plus a divided by s plus a square plus b square formula is what? Minus minus 1 minus e power minus at. A is 0.5. So minus 0.5 into t is 1 second. At into cos pt. cos p value is what? 0.866. 86 into t value 1 z power minus 1 divided by denominator term is what? 1 minus 2 e power minus at cos pt z power minus 1 plus e power minus 2 at into z power minus 2. Here t equal to 1, so that's why I am not mentioning that 1 value. This is for the formula of second term. What about third term? Plus. So plus this constant value 0.577, then this is p divided by s plus a square plus b squared. So formula is e power minus at sin bt z power minus 1 divided by 1 minus 2 e power minus at cos bt z power minus 1 plus e power minus 2 at into z power minus 2. Then simplify using calculator e power minus 1 value. So e power minus 1 value is 0.3678. The numerator term e power minus at cos bt, that is 0.66 divided by denominator term. This is third term, numerator and denominator. The denominator in these two terms are common, so take LCM. So multiply this two term and simplify it. Finally we'll get this is the digital Butterworth filter transfer function. So here you have to remember that digital filter design using impulse invariance method having a two formula. One is 1 divided by s minus pk, another one is s plus a divided by s plus a square plus b squared, and b divided by s plus a square plus b squared. So if that equation is having to find direct poles, then we can choose the first formula. If it is not possible, then you must do with that second and third formula. According to that formula, you just modify that denominator as well as numerator, right? Thank you all.